The topic that we have, it is the factors affecting the electron affinity. Now what type of factors are going to affect the electron affinity? Let's discuss it in this section. So there are mainly four factors that are going to affect the electron affinity. You must know that what does mean by electron affinity. It is the affinity of the nucleus of an atom of an atom towards the added electron. When we add an electron to the valence shell of an atom of an element, then there is a release of energy. That release of energy is known as electron affinity. So there are many factors that affect the electron affinity when we move from top to bottom in the groups, and as well as when we move from left to right in the periods of periodic table. So let's have a look on these factors, that what type of factors can affect the electron affinity. So basically there are four factors that can affect the electron affinity. The first one factor we have, it is the nuclear charge. Nuclear charge, it is the positive charge on nucleus. Second factor is shielding effect. And third one factor we have electronic configuration. Electronic configuration, you can also write it as E dot C. Configuration as E dot C. And the fourth one factor that is going to affect the electron affinity, it is the atomic size. Atomic size भी कह सकते हैं and atomic radii. So atomic radius. How can the atomic radius affect the electron affinity? First of all, we must have a look on the relationship between atomic size and electron affinity. When we move amperes from left to right, from left to right, there is decrease in atomic size. When atomic size is going to decrease, it's mean the distance between the nucleus and valence shell is going to be decrease. So the valence shell is coming close to nucleus. When it come close to the nucleus, now the nucleus will pull the added electrons more forcefully, and more energy will be released. And when more energy will be released, it's mean it is having higher or more electron affinity. So atomic size of an atom is having relationship. When there is atomic size larger, then the electron affinity will be less. So there is an inverse relation between atomic size and electron affinity. When atomic size is more, affinity will be less, and when electron affinity is higher, then atomic size will be smaller. Next, we have the second factor that affect the electron affinity. It is the nuclear charge. So how the nuclear charge can affect the atomic or electronic affinity for of an atom for the added electron? Nuclear charge is a charge on nucleus, and the charge on nucleus is positive, and this positive charge is due to the presence of protons. So because protons are present in the nucleus. Now if there is more nuclear charge on an atom, it's mean more positive charge, and this positive charge will attract the added electron more forcefully, and more energy will be more energy will be released, and more energy will be released, it's mean there is higher electron affinity. It's mean there is a direct relation between electron affinity and nuclear charge. When nuclear charge is higher, then electron affinity will be more. So this is a simple relationship that is between the nuclear charge and electron affinity, or how the nuclear charge can affect the electron affinity. If nuclear charge is higher, then electron affinity will also is going to be increase. So next we have the third factor that can affect the electron affinity as well. It is the shielding effect. So shielding effect, it is basically the reduction in force of attraction between the nucleus and valence electrons. And why there is a reduction? Due to the inner shells, there is a force of reduction between the valence electrons and the nucleus. So this is known as shielding effect. When shielding effect is going to increase, it's mean the more inner shells are going to be added into the shell, it's mean the nucleus is going away. So the nucleus is going away from the valence shell, or the valence shells are going away from the nucleus. It's mean we have the simple relationship between the shielding effect and the electron affinity. For example, it is having four shells. Now the distance between the nucleus and the valence shell is going to be increase. No, now the nucleus will pull the electrons with less force because there is increase in the inertia. So when shielding effect is going to be increased, electron affinity is going to be decrease. So by the increase of shielding effect, electron affinity will be decreases. So there is a inverse relation between shielding effect and the electron affinity. So shielding effect is having inverse relation with the electron affinity. Next, we have the last one factor that is going to affect the electron affinity. It is the electronic configuration. It depends upon the two things: the completely filled orbits or orbitals, completely filled shells we can say, or the incomplete shells. So these are the two things: when atom is having completely filled shell or outermost shell, or when it is having incomplete subshell or shell. When it is having complete subshell, so there will be no electron affinity by the atom, and when there is incomplete subshell, then the atoms will release the energy. The energy is electron affinity, and more they can have more electron affinity. So this is the effect of electronic configuration over the electron affinity. I hope you guys understand about that, and if you have any queries, you can ask me about that in the next section. For that time, have a good day, and Allah Hafiz. Thank you.